So now we will move on to exercise 1E. And that's more about the stealth quadratics. When it isn't exactly x squared, x and a constant, but can be turned into something like that. So for the first set of questions, we just need to solve the equation. So here we have x to the power of 4 minus 13x squared plus 36 equals 0. And if it helps, we can say we can let u equal x squared. And that makes this u squared minus 13u plus 36. And now you can see that certainly looks like a quadratic. And we can simply factor this. Nine and 4, because minus 9 minus 4 is minus 13, and minus 9 times minus 4 is 36. And then we can say that, well, u will either equal 9 or u will equal 4. Thus, x squared equals 9 or x squared equals 4. So x equals 3 or x equals minus 3. Or x equals 2 or x equals minus 2. So we have 4 solutions. Now the next example is x to the power of 6 minus 7x cubed minus 8 equals 0. And hopefully you're seeing a pattern where we can only do this when you have the constant, some power of x, then double that power. And here we would say let u equal x cubed. Now we replace every x cubed we have with u. So that becomes u squared minus 7u minus 8 equals 0. Then we will factor this. So u will either equal 8 or u will equal minus 1. So x cubed equals 8 or x cubed equals minus 1. So we take the cube root of both of those, so x is either equal to 2 or x is equal to minus 1. C, x to the power of 4 minus 6x squared plus 5 equals 0. Alternatively, you can just automatically factor, and I'll show you how you can do this in that way. You can just factor it out as x squared in the first place. And so instantly you cut out the middleman, and so x will either equal root 5 or minus root 5 or 1 or minus 1. Two x to the power of 4 minus 11x squared plus 5 equals 0. And we'll do our normal AC is 10, that's 2 times 5. Now we want two numbers that multiply to 10 and add to minus 11. So to me that's going to be minus 1 and minus 10. And then we factor that x squared out. Right, so x squared will either equal 5 or x squared will equal 1/2. So x equals plus or minus root 5 or plus or minus root of half. So that's plus or minus 1 over root 2, which is root 2 over 2. So we get x equals root 5, x equals minus root 5, x equals root 2 over 2, x equals minus root 2 over 2. E, 3x to the power 4 plus x squared minus 4 equals 0. AC equals negative 12 plus 4x squared plus minus 3x squared plus 4x squared minus 4 equals 0. Factor out 3x squared. And so we get this. Now, if we have a look at this, and we see that x squared equals minus 4 over 3, or x squared equals 1, it's only asking for real solutions, so we can't take the root of a negative number, so no real solutions you would write there. But on this side we can do x equals 1, x equals minus 1. Right, 8x to the power of 6 minus 9x cubed plus 1 equals 0. AC equals 8, 8x squared minus 8x cubed minus x cubed plus 1 equals 0. Factor out the x cubed. Right, so we get x cubed equals 1 over 8 or 1. And then so x will be 1/2 or x will be 1. G, x to the power of 4 plus 2x squared minus 15 equals 0. X to the power of 4 plus minus 3x squared plus 5x squared minus 15 equals 0. If we factor out the x squared, we get x squared minus 3, and then we get over here x squared minus 3 again, but with the 5 extracted. Again, we have to say there's no real solution for x squared equals minus 5. So then x squared has to be 3, then x will equal plus or minus root 3. So x equals root 3 or x equals minus root 3. H, x to the 4th plus 9x squared plus 14 equals 0. Now we can factor this, x squared plus 7 and x squared plus 2 equals 0. But already we can see both of those are going to get x squared equals a negative number, so there's no real solutions. I, x to the power of 8 minus 15x to the power of 4 minus 16 equals 0. And let's factor this. X to the power of 4, we halve that power there. Minus 16. X to the power of 4 plus 1 equals 0. So clearly this one's going to be no real solutions. For an odd power, you can have negative numbers, but for an even power, you can only have positive numbers in real numbers. So x equals 2 or x equals minus 2. J. 32 x to the power of 10 minus 31 x to the power of 5 minus 15 equals, no, minus 1, sorry, equals 0. Right, so we want something that multiplies to negative 32. And we're getting something like this. Now we factor out. So we get x to the power of 5 equals negative 1 over 32, or x to the power of 5 equals 1. So for 1, it'll just be 1, and you can't have negative 1 as a solution to that. And on this side, you can take the fifth root of a negative number, and that'll just be negative half. Because remember, 3 negative numbers multiplied together, one negative is just negative. You multiply a negative by a negative, that's positive. And because that will now be a positive, if you then divide it by a negative, that'll just be a negative again. So that's why you can take the odd roots of negative numbers, but not for even powers, not even roots. Okay. 9 over x to the power of 4 plus 5 over x squared equals 4. There are a few approaches you could take. I would say doing a use substitution would be best. I can show you maybe a couple ways though. One way would just be to multiply everything by x to the power of 4. You multiply everything by x to the power of 4, you get 9 plus 5x squared equals 4x to the power of 4. 4x to the power of 4 minus 5x squared minus 9 equals 0. AC equals minus 36. And then you factor this out. 4x to the power of 4 minus 9, plus 4x squared minus 9x squared minus 9 equals 0. 4x squared, x squared plus 1 minus 9, x squared plus 1. Right, and then this just gets you no real solutions. So 4x squared will equal 9, x squared is 9 over 4, x will be root of that. So x is either 3 over 2 or x equals minus 3 over 2. You additionally could have said let u equal 1 over x squared, and then done a u substitution, doing 9u squared plus 5u minus 4 equals 0, and then solved it in the same way. Or you could have just factored this out initially anyway, going and you could have just tried to factor it without doing any removing from the denominator or anything like that. L. 8 over x to the power of 6 plus 7 over x cubed equals 1. L And I'm going to do the same thing as I did before, multiplying everything by x to the power of 6. Make it equal to 0. So we get x cubed is either equal to 8 or x cubed is equal to -1. So we get x equals 2 and x equals -1. Two. First one is, we're just solving equations at this point. 2x minus 9 root x plus 10 equals 0. Now remember that root x is the same as x to the power of half, and that half is half the power of 1. So we can do the same thing as before. You could say let u equal root x. 2u squared minus 9u plus 10 equals 0. Ace equals 20. 2u squared minus 4u minus 5u plus 10 equals 0. 2u minus 2 minus 5 bracket u minus 2 equals 0. 2u minus 5 bracket u minus 2 equals 0. U will equal 5 over 2 or u will equal 2. And this means root x equals 5 over 2 or root x equals 2, meaning x will be 25 over 4 or x will equal 4. Or B. We should expand this first and then remove that 6 from the other side. And let's just try to factor this. So we can still do factoring as usual. Now one of them will say root x equals -3 and then root x equals 2. But remember, we define this symbol, the principal root, as being only the positive, because on a graph, if you did plus or minus, then it would fail the vertical line test and not be a function. So we only take the positive. So we reject that solution and then only take x as being equal to 4. C. 6x minus 17 root x plus 5 equals 0. AC equals 30. 6x minus 15 root x minus 2 root x plus 5 equals 0. 3 root x we can extract from there. 2 root x minus 5. And then we're just getting 2 root x minus 5 over here. So we get 3 root x minus 1 bracket 2 root x minus 5 equals 0. So root x will equal 1/3 and then root x will equal 5 over 2. So x will either be equal to 1 over 9 or it will be equal to 25 over 4. D. 10x plus root x minus 2 equals 0. AC equals minus 20. 10x plus 5 root x minus 4 root x minus 2 equals 0. Extract the common factor of 5 root x from the first half, and then the common factor of 2, or I should say minus 2, from the second half. Five root x minus 2, 2 root x plus 1. Right, and now we get root x equals 2 over 5, or root x equals minus half. That we reject, but this one we can keep. So we get 4 over 25. E. 8x plus 5 equals 14 root x. Therefore, 18 minus 14 root x plus 5 equals 0. AC equals 40. So we need two numbers that multiply to 40. Here we go, this should be looking very easy for you now. Right, root x is a half, x is therefore going to be a quarter. Or it can be 5 over 4, meaning it's 25 over 16. F. 3 root x plus 5 over root x equals 16. Again, as I said for the one that was like 9 over x to the power of 4 or something like that, I recommend you either do a u sub or you get rid of those denominators. So this becomes 3x plus 5 equals 16 root x. Plus 5 equals 0. AC equals 15. 3x minus 15 root x. 15 root x minus root x plus 5 equals 0. 3 root x minus 5 minus root x minus 5 equals 0. 3 root x minus 1 bracket root x minus 5 equals 0. Root x equals 1/3, x will be 1/9, or it can equal 5, meaning x will be 25. So that's the end of question 2. Now we'll go on to question 3. Right, and it tells us that the curve y equals 2 root x and line 3y equals x plus 8 intersect at A and B. A. The first thing we need to do is write down an equation satisfied by the x coordinates of A and B. Right, so we would make y the subject here by dividing by 3, and then would set the equations to equal each other. So x plus 8 will now equal 6 root x, and x minus 6 root x plus 8 equals 0. And B, we need to solve that equation and then find the coordinates of A and B. Just factor this out. Root x equals 4, x equals 16, root x equals 2, x equals 4. And now we put this into the 2 root x, y equals 2 root 16. That's just 8. And y equals 2 root 4, which is just 4. So we get A and B at 16, 8, and 4, 4. C. Find the length of the line AB. We use the distance formula. It's just Pythagoras. Right, so that's 4 root 10, because this is just 16 times 10. And so we can remove that 4. Question 4. Right, we're given a bit of a diagram of something like this. This point is 1, 0. This point is 49 over 4, 0. And this part here is 0, 7. And this is the curve ax plus b root x plus c. And so we need to just determine what a is, and what b is, and what c is. And what this is saying is that if we substitute in 0 for x, we'll get 7. These all become 0, so c equals 7. With that being known, we can figure out the other ones. A times 1 plus b root 1 plus 7 will equal 0. So literally a plus b plus 7 equals 0. A plus b equals minus 7. We can do further rearrangement if we need later. Now, a times 49 over 4 plus b root 49 over 4 plus 7 will equal 0. 49 over 4 plus 7 over 2b, sorry, 49 over 4a plus 7 over 2b plus 7 equals 0. So now we just need to cancel some things out, try to eliminate a variable and solve these equations simultaneously. I would multiply all of this by 7. Then I multiply all this by 2. Then I'd subtract both of them. These will both eliminate. And then so if we divide that by that, we'll get a equals 2. And then b is just going to be minus 7 minus a. So minus 7 minus 2, which equals 9. So therefore we can say a equals 2, b equals 9, c equals 7. Oh, that's minus 9, sorry. Minus 9. And I think that's right. Now, 5. We've got another type question like this. It looks a bit like this. This is 2, 0. This is 4, 0. This is 0, 90. And the graph is y equals a multiplied by 2 to the power of 2x plus b to the power of b times 2 to the power of x plus c. When x is 0, this becomes 2 to the power of 0 plus b 2 to the power of 0 plus c. So that's just a plus b plus c. and that equals 90. Then a 2 to the power of 2x plus b 2 to the power of x plus c will equal 0 when we replace x with 2. This would become 4 and this would become 2. And we can simplify this. And then we can do the same for the other one, which is 4. So that's 256a plus 16b plus c equals 0. Right, and at this point I'd probably rearrange c to be 90 minus a minus b. This probably will make it a lot easier. And then I can substitute the c for 90 minus a minus b. Although I don't actually know, that does very easily eliminate. So if I were to subtract these away from each other, those c's would eliminate. So you get 240a plus 12b equals 0. And then actually, I still will have to do some substitution for the c, because of that. So c will equal minus 4b minus 16a. So a plus b minus 4b minus 16a will equal 90. So we get minus 15a minus 3b equals 90. Multiply the bottom one by 4, minus 60a minus 12b equals 360. And so we add those two together to get 180a equals 360. And you see we add that because 12b plus minus 12b is 0. So they eliminate in that way. So a will equal 2. And we can just continue with the substitution. So 3b will equal minus 15a minus 90. So then b will equal minus 5a minus 30. So minus 5 times 2 minus 30 is just minus 40. Now c is simply 90 minus a minus b. So that's 90 minus 2 and plus 40, because minus 40 is the same as plus 40. So we get 128. A equals 2, b equals minus 40, c equals 128. And that's the end of 1E. In the next video, we'll be moving on to 1F, which looks like it's all about parabolas and the shapes and the symmetry and whatever.